Hello everyone. So guys, today's lecture will cover aerodynamics syllabus and reference books which are required to cover your GATE syllabus. This is one of the most important lecture before starting your GATE preparation. The reason being aerodynamics has so many small topics and it is very easy to not able to properly cover the syllabus if you don't know what things are coming in the GATE exam. So I will go into every small bit of detail, what topic we need to study and which book to refer for that particular topic. And the another important thing before starting the lecture, I want you people to understand before you're starting your gate preparation and maybe starting with aerodynamics, that don't break the sequence of the syllabus. So you have to study all the topics in the sequence I'm going to give you today. Then only you will understand the concept, and you will not only be learning formulas, and you will not only be solving gate numericals, you will be understanding the concepts as well. Now, before starting the video, I insist you people please like the video, subscribe to the channel. This gives us more motivation to publish some good videos which will help you in your gate preparation. All right. So I'll straight away start with the weightage first. So when I say aerodynamics, typically I'm including gas dynamics in it. And if you see, it is comprising total of 20 marks in your gate exam. This is also asked in 2025, and I'm giving you an average weightage as well. So gas dynamics included in it, you will come to know what do you mean by gas dynamics in this syllabus. So this is roughly around 20 marks, which is a heavy weightage for your gate syllabus. Now, going into the syllabus in more detailed way. So I have broadly divided this into four legs. First one is fluid mechanics. All right, I will go in detail in each one of them in the coming slides. Then I have discussed something which is low speed aerodynamics. We will typically talk about incompressible flows here. Then we will enter into high speed aerodynamics, in which we will talk about compressible flows, typically subsonic, right? And all the topics we need to cover in this. And then lastly, which is gas dynamics, which covers not only supersonic, you will start from subsonic flows and convert your flows into supersonic. But if you see the weightage, this is the most heavy topic. It's a favorite topic for gate examiners to ask in aerodynamics syllabus. And then this incompressible flows is also a heavy topic. Apart from this, you have fluid mechanics, which is typically asked for 4 marks, sometime three, sometime five. And high speed compressible flows is typically asked for 2-3 marks. You will come to know what are the inside topic you need to understand, because if you go and open any standard textbook, right, you will not find these words inside it. So you need to understand what all topics are included in each of the headings here. So I'll first go inside fluid mechanics. I told you start in the same sequence. So first you should start your preparation with fluid mechanics. Now don't read entire fluid mechanics which you have done in your BTech academics. When I say basics, just quickly revise what are basic fluid dimensional, like what are the units corresponding to it, what is pressure, what is temperature, density, different kind of flows. Very basic. So it should not take much time. You should quickly just brush up the basics. It is not required for your gate much. Then this is an important topic here, conservation equations. And in this, you should look into continuity equation, momentum equation, Navier-Stokes equations, and Bernoulli's equations, how each equation is derived from the another. So you have Bernoulli's equation, you have Euler's equation, which is one form of Bernoulli's equation, which is derived from Euler's form. So all conservation equations in differential form, integral form. They are asking this for 1 mark in your gate exam, but they have asked this like 4 or 5 times. Then we should also look into laminar and turbulent flows. These are typically 1-2 mark numerical you will find. Boundary layer is an important topic. So you will find one numerical for sure from boundary layer. And then dimensional similarity. When I say dimensional similarity, you know you have prototypes, different kind of numbers you need to study in this, and so on. So restrict fluid mechanics. Don't forget the weightage, and depending upon that, you should spend time in that topic. Finish these topics. In the process, solve all the gate numericals from 2007 till 2025, you will also get an idea whether you have studied all the topics or not. This will cover entire gate syllabus, whatever questions are coming in all the years, in all 18 years, whatever gate aerospace we have, and 2026 will also not be different. Now, for books, I prefer any book from R.K. Bansal or D.S. Kumar for basic fluid mechanics, and I will keep this book, Fundamentals of Aerodynamics by John D. Anderson, on every slide because this is kind of a Bible for any person who is studying aerodynamics. So, at least for these portions, I'll suggest you can go for R.K. Bansal and D.S. Kumar. But if you see this topic, right, conservation equations, you can refer this from Fundamentals of Aerodynamics by John D. Anderson. They have nicely given all the differential form, integral form. They have given examples of it. It's a very starting unit. So you can refer this book for sure, at least for conservation equations. Remaining topic, don't go into John D. Anderson. Do any standard textbook, Bansal, D.S. Kumar, or whatever book you have done in your academics is perfectly fine, not a problem. Now, in this, people also study ideal potential flow. But what I have done is I have taken that ideal potential flow in our next topic, which is low speed incompressible flows. Now, when I use the word low speed incompressible flows, keep this in mind. We will typically talk about anything which is flying in incompressible zone, where Mach number is less than zero point 0.3. And you should not break the sequence. You will understand why. So, first, you will understand what are ideal potential flows. Again, this topic of ideal potential flows can be studied from any standard textbooks. So, in this, you will be talking about uniform flow, source, sink, doublet. And then, once you have understanding about all vertex flows, free vertex, force vertex, once you have understanding about these kind of flows, you know what is stream function, what is potential function. Then you will develop what is known as a cylinder. And then you will develop a lift over that cylinder. This is your step one. In step one, we will see how lift is developed over a circular cylinder. And this cylinder will produce lift. Then, once you understood and have all the understanding about stream function, potential functions, what you will do is you will go to Kutta-Jankowski transformation, and this Kutta-Jankowski transformation will convert this cylinder into different kind of airfoil. So you will have cambered airfoil, you will have symmetric airfoil, you will have flat plate airfoil. So all these cylinders will be transformed. You will see how the transformation Kutta-Jankowski has accomplished. And they have asked this only for 1 or 2 mark, but I'm telling you the sequence which is required. So once you know the lift generated over cylinder, you convert this cylinder into airfoils, different shapes. And then in thin airfoil theory, you will generate lift over these airfoils. So understand the process, guys. You have, with the help of fluid mechanics tools, generated a cylinder which is producing lift. And then with the help of transformation and applying some theory of airfoils, you have now airfoils which are generating lifts. So this is the sequence. If you start with thin airfoil theory, there is no point of understanding how this airfoil is generated or how lifts are getting generated. You cannot learn that way. So follow the sequence in which I am giving you these notes. Once you have this thin airfoil theory ready, Kutta-Jankowski theorem, maybe you people have seen it, something like rho u tau per unit span. Some like this formula. This is known as Kutta-Jankowski theorem. And then you will learn about finite angle wedge airfoils. All these are nicely given in books. I will come to that. And once our airfoils are producing lift, in last step, we will generate the wing with that airfoil, and which comes under Prandtl's lifting line theory. So understand, you have developed a cylinder, which is not reality. This is ideal world. No one will going to generate or use a cylinder in your aircraft. Then with the help of some equations and transformations, you convert that cylinder into airfoils. And then with the help of lifting line theory, you convert that airfoil into a wing. And that's how the wing will produce lift in the end. Now, in the process, you will learn many things. What is elliptical lift distribution? What is lift curve slope of an airfoil, lift curve slope of a wing? And in this, you will also learn about what is known as induced drag. Now, I'm not going into technicality of each topic, but you will find these catchy words when you're studying these topics. So go in the sequence, guys. Absolutely don't break the sequence. It should be followed in the same way. I already told you ideal potential flows you can study from any standard textbook. You will directly find this chapter in any of the book. Then these theory, right? Kutta-Joukowski thin airfoil theory, Kutta-Joukowski theorem, you will find in Horton and Carpenter. So don't refer this book much apart from this topic because this is very confusing and old book. You will not find it interesting, very less images, and bit tricky to understand as well. If you have some good study material books, it's really good. This will be done in 2 3 hours if you follow proper notes or some lectures. If not, you're doing it on your own. Just restrict Horton and Carpenter only for this topic. Otherwise, please don't do it. And then the last topic, Prandtl lifting line theory, is must and best given in John D. Anderson. So I hope you people understood now the sequence. This in D.S. Kumar or R.K. Bansal. Then these three remaining topics of thin airfoil theory should be done from Horton and Carpenter. And the last one, Prandtl lifting line theory, is 100% you have to do. This is fixed topic coming in your GATE exam. So out of six, you can imagine three will come from this topic itself. Should be done from John D. Anderson. All right. Now, when I say last book, which is Clancy, Clancy is a very special book in aerodynamics which doesn't have any numericals. It's like a novel, guys, and it covers entire theory in beautiful form. So it gives you information about what do you mean by induced drag, how it varies, what do you mean by aerodynamic center, center of pressure, what do you mean by different kind of airfoils. And this is the reason I have mentioned aerodynamics by Clancy. So you will not able to solve any numerical if you only refer Clancy because you need to solve some numerical answer type questions also, right? For GATE. But this gives you beautiful insights about topic, variations in things, how induced drag is dependent, how it is. But don't go into this unless and until you have finished these three topics from these standard textbooks. Now, apart from this, I want to write this, hence, I have not. There are some additional topics, small topics, which you should cover before closing this. Like, understand about NACA airfoils. This was also asked for 1 mark in 2025, and they have asked this 5 6 times in your GATE exam. So, NACA airfoils is an additional topic you should refer. All 4 5 6 digit airfoils. Then you should definitely 100% understand about aerodynamic center and center of pressure. These two things I insist. And third, people say which are high lift devices. So again, if you're following any proper study material books, right? I have actually given in the study material books in the same format. So you will go in ideal potential flows, then you understand the transformation, then you understand the thin airfoil theory, develop the wing, and then you will understand about different kind of airfoils, aerodynamic center, center of pressure, and then high lift devices. So please keep this in mind. These three topics are very much necessary for your GATE exam and read about it. All right. Once you start solving the GATE numericals, right, you will automatically come to know which topic I should solve numericals also and which topic is only for theory. And if not, you can always WhatsApp me and I can help you in whether you need to solve numericals or not or which chapter to refer. You can always contact me. So second topic is done. Now what we will do is we'll try to increase our speed. So I told you this is done typically with a Mach number of 0.3 where you are talking about incompressible zone. So in this, we will go above 0.3. That means we enter into compressible zone. So understand the sequence. We understood the fluid mechanics. Then we started our speed and only studied when we were flying till Mach number of zero point 0.3. Then we increased our speed. We are flying at a Mach number of zero point 0.5, zero point 0.6, maybe 1, maybe more than 1. So in compressible zone. And in this first topic, you should refer is Prandtl-Glauert correction factor. It's a very powerful formula asked in your exams also. It gives you all the quantities, pitching moment coefficients, lift curve slopes. It gives you CL, that means lift coefficient, drag coefficient, induced drag coefficient, everything. Then once you start traveling faster, right, we need to understand these two important topics. Again, theory topics typically critical Mach number and drag divergence Mach number. Then only two questions asked in your exam up till now from linearized supersonic flow, but that doesn't mean it will not come in 2026. So you have to do it. And in that topic, only one subtopic which is always coming in your exam is flat plate at an angle of attack in subsupersonic flow. So you will be calculating lift coefficients, drag coefficients, all these things over a flat plate airfoil. Now, all these topics, although it looks intriguing, it looks like where we need to find this, they are beautifully given only in our Bible, which is Fundamental of Aerodynamics by John D. Anderson. You need not to roam any other standard textbooks, just follow this. You will find this in the same sequence, properly explained. You don't need any explanation if you read it line by line. But again, as I told you, you will only understand Prandtl-Glauert correction factor if you understood lifting line theory. If you are skipping this and trying to understand all these topics, right, it will absolutely make no sense. So follow this sequence. In the end, I will tell you the timeline also. For all the people, those who are trying to do it on their own, how much time roughly you should have in your mind. It's not like you will do this in 3 months. Doesn't make sense. You have remaining 6 subjects also. So I will give you a rough estimate depending upon, let's say you're studying for 2 hours, 3 hours a day. Let's discuss this in the end. And then the last topic, which is the most heavy topic weightage wise, which is gas dynamics. And in this, you should definitely cover these topics, and it is huge. So, isentropic flows. So, this will talk about all stagnation pressure, temperature, entropy, isentropic relations, everything. Very, very important topic. This is where all difficult questions are coming in your GATE exam. After this, the easiest topic starts. So, normal shock wave, oblique shock wave, expansion fan. Keep this in mind. All these are for supersonic flows. I told you I'm increasing the speed slowly. Then CD nozzles for sure. Again, here the complicated questions comes. So isentropic flows combined with CD nozzles will give you some difficult conceptual questions in your GATE exam. And then in last 3-4 years, they are entering into what is Fano flow and Rayleigh flow. So these are frictional flows and these are heat addition or heat rejection flows. And this is again, we'll talk about supersonic flows itself. So, all these topics. Now, coming to books, till this point, you will find them again in our John D. Anderson. And believe me, guys, you need not to go to any book. More than enough, more than enough for solving any gate numerical. Now, apart from this, people typically follow SM Yaya. They also follow Zucker. These are typical gas dynamics books. You can do that. I'm not going to say that you cannot refer other books, but this is the book which will give you complete understanding, all equations. You just need to practice more numerical. People also follow Radhakrishnan perfectly fine, very detailed, more number of numericals to practice. So I suggest read it, understand the theory, and then practice numericals from Radhakrishnan maybe. But that should be second part. First, read it, try out your gate questions. I'm posting all the gate solutions on the channel, so you will be able to find all gas dynamics or any topic questions. And then, if you want to practice more, get some assignment sheets. If you're not enrolled with any institute, if you're doing it on your own, practice Radhakrishnan questions. That will be more than enough. And as I told you, I always keep Clancy as a book, as a handbook for aerodynamics. This is the whole syllabus of aerodynamics, and please try to follow this in the same sequence. You can study gas dynamics separately by breaking the sequence because gas dynamics will also help you in propulsion. In propulsion, when you start, you will need isentropic flow equations. So you can start gas dynamics separately. Typically, I do this in my lectures, in my classes. The faculty will start with gas dynamics and then may follow this. So it totally depends whether you want to be doing this in parallel with propulsion or not. But if you're doing aerodynamics, please start from here. Then you move on to these topics. Now, coming to timelines, last point, and then we will close this. Don't spend much time in fluid mechanics. I suggest a week time is more than enough. 1 week is more than enough. Now, when I say 1 week, I'm assuming that you people are studying at least 3 hours a day. If you people are not attending any lectures, any classes, or you're not seeing any videos. If you're seeing any videos, maybe 2 hours you learn something and 1 hour you practice. This is more than enough to finish our GATE aerospace fluid mechanics portion. All right. When it comes to this is a heavy topic in aerodynamics. So you need to spend time here. So what you can do is spend time, read things, solve all numericals from 2007 till 2025. Don't close the topic unless and until you have solved all the numericals. And you can spend roughly 2 weeks here. All right. Then when it comes to all these numbers, although I prefer if you are really serious and doing it properly, 3-4 days are more than enough. But just to be on the safer side, let's give 1 more week. And then when it comes to aerodynamics, gas dynamics syllabus, I prefer saying give 2 weeks, and additionally you can give 1 more week. The reason being, this should be your strongest topic. This not only gives you 8 marks in your gate exam, it makes you so strong in propulsion as well. So if you're good in aerodynamics, right, gas dynamics portion, you will be super strong in propulsion, and you will be understanding all compressor, turbine, jet propulsion, rocket propulsion equations, because all these properties, isentropic flows, CD nozzles, all kind of shock waves will be present in your aircraft engines, right? In rockets also you have all these properties. So if you see roughly, I expect you people to finish this 20 mark of your syllabus when you're starting it for the first time. You should give round about, if I'll say 6 to 7 weeks. So I can say 1.5 months or 1.5 months. This should be your, if you're doing it on your own. If you're doing in classes, definitely this will be done very, very shortly in lesser time. But that's not the motive of this lecture. The motive is which book to refer. And guys, I completely agree that maybe some people will have some doubt here and there after listening to this lecture. So as I told you, you can always connect with me on WhatsApp. Try to WhatsApp me on this number, as because sometimes it is very difficult to attend all the calls. So you can WhatsApp me. We can have discussions. I can help you in between. You can write an email to me, or you can visit the website, and anything, any mode you can try to connect with me. Hopefully, you find this lecture good to start your preparation. And as I told you again before as well, please like it. I get motivation. Like, these lectures are making sense. These are helping people who are preparing for Gate Aerospace. And then I can prepare videos for all other topics as well. And then we can have Gate solutions, maybe some lectures, some difficulty topics. You can even put in the comment if you need any lecture on any particular topic. Let's say you need lecture on lifting line theory and so on, or Gate solutions for this. So we can prepare the lectures accordingly. All right. Thank you so much, guys. Bye bye. Take care.